China just deployed millions of ducks into rice paddies across the country. What happened next completely transformed how the world thinks about farming. This wasn't some small experiment. This was a full-scale assault on one of agriculture's biggest problems. And the results defied every expert prediction. You're about to see how nature outperformed billions of dollars in chemicals. But to understand why China did this, you need to see the crisis that was spiraling out of control. China's rice fields were being eaten alive. Locusts, plant hoppers, and stem borers were tearing through millions of acres. These pests weren't just damaging crops. They were destroying them completely. Farmers watched entire harvests disappear in days. And every year, it got worse. Walk through a rice paddy during peak infestation, and you'd see plants stripped bare. Stems hollowed out from the inside. The sound of millions of insects chewing was constant. Fields that should have been green were turning brown, dying. This wasn't happening in just one province. This was nationwide. So farmers did what they'd been doing for decades. They sprayed pesticides, more pesticides, stronger pesticides. Tractors rolled through paddies, pumping toxic clouds over the crops. The smell alone was overwhelming, acrid, chemical, and it worked for a while. But then the pests came back, stronger, more resistant. The survivors had adapted. Within a season, the same pesticides that had worked before were useless. Farmers had to spray even more, switch to stronger chemicals. The cycle never ended. Here's where it got really bad. The pesticides weren't just killing pests anymore. They were poisoning everything. The soil collapsed. The water turned toxic. Fish died. Birds stopped coming. And the chemicals were building up in the rice itself. Farmers were spending fortunes on pesticides that barely worked. They were trapped. The more they sprayed, the worse it became. Every year required more chemicals, more money, more damage. Researchers knew the system was collapsing, but every solution involved more chemistry. Nobody was questioning the fundamental approach. Then scientists started looking at something everyone had ignored for decades. Ducks eat insects. That's what they do. They waddle through water, pecking at anything that moves. And rice paddies are flooded fields full of insects. It seemed almost too simple. But when researchers actually tested it, the numbers were staggering. A single duck could consume hundreds of insects per day. Locusts, plant hoppers, beetles, worms. Ducks didn't care. They ate them all. The researchers set up small test plots, released a few dozen ducks into rice paddies, and watched what happened. The ducks went to work immediately. They paddled through the shallow water, heads bobbing, beaks snapping. A plant hopper taking flight was intercepted mid-air. A stem borer crawling up a rice stalk was plucked off instantly. The ducks were relentless. Within days, the insect populations in those test plots had crashed. The fields were nearly clean. And the ducks never slowed down. They kept hunting from sunrise to sunset. Every metric pointed to the same conclusion. This actually worked. But nobody believed this could work at scale. Modern rice farming was built on chemicals. The idea of replacing that with birds seemed absurd, impossible. How do you manage millions of ducks across millions of acres? How do you time it with planting cycles? How do you keep them from destroying the rice they're supposed to protect? Every expert said it couldn't be done. The logistics were too complex. The scale was too massive. Agricultural conferences dismissed the idea. Chemical companies laughed it off. Government officials called it impractical. The entire establishment was unified. Ducks couldn't replace pesticides. But China wasn't asking for permission. They looked at the data from those small trials and saw a solution. A real one. Not a marginal improvement. A complete replacement. What happened next changed everything. China started deploying ducks into rice paddies. Not hundreds, not thousands, millions. They coordinated releases across multiple provinces simultaneously. Farmers who'd never worked with ducks were suddenly managing flocks of 50 to 80 birds per acre. The ducks were released right after rice planting, when the seedlings were young and the pest populations were just starting to build. The initial rollout was massive. Breeding facilities across the country ramped up production. Millions of ducklings were hatched, raised to the right age, and distributed to farmers. Trucks carried crates of ducks to remote villages. The scale of the operation was unprecedented, and immediately, problems emerged. Ducklings were vulnerable to predators. Hawks circled overhead. Snakes slithered through the water at night. Rats attacked at the field edges. Farmers had to build protection systems, netting, enclosures, guard dogs. The mortality rates in the first weeks were higher than expected. The timing had to be perfect. Release them too early, and the ducks would trample young rice seedlings. Too late, and the pests would already be out of control, coordinating millions of ducks across different climate zones, different planting schedules, different rice varieties. It was chaos. Northern provinces planted in April, southern provinces in March. The duck releases had to match perfectly. Disease was another nightmare. That many ducks in close proximity created massive risk. Veterinary teams had to monitor duck health across the entire program. Sick ducks had to be identified and removed immediately. But then something unexpected started happening. The ducks weren't just surviving. They were thriving. The rice paddies provided everything they needed. The ducks adapted faster than anyone predicted. They paddled through the flooded fields, gobbling up every insect they could find. They didn't get tired. They just kept eating, day after day. And the pest population started crashing. Farmers watched in disbelief as their fields stayed clean without a single spray of pesticide. The ducks were actually working. And those numbers revealed something nobody saw coming. The ducks were eliminating over 90% of harmful insects. 90%. Without chemicals, without resistance, without contamination. Plant hoppers that used to devastate entire fields were disappearing. Stem borers that burrowed into rice plants were being eaten before they could do damage. Locusts didn't stand a chance. Researchers documented everything. They set up control fields with traditional pesticide use, comparison fields with ducks. The results weren't close. The duck fields had 90 to 95% fewer pests. The pesticide fields were still dealing with infestations despite multiple chemical applications. The ducks were outperforming decades of chemical research. But here's what shocked researchers even more. The rice yields weren't just staying the same, they were increasing. Fields with ducks were producing 15 to 20% more rice than fields with pesticides. Nobody expected that. Scientists figured out what was happening. The ducks were stirring up the water as they paddled around. That constant circulation was oxygenating the soil. Rice roots were getting more oxygen. Stronger roots meant healthier plants. Healthier plants meant better yields. Their droppings were fertilizing the fields naturally. Duck manure is rich in nitrogen. Every duck was depositing nutrients directly where the rice needed them. Farmers were getting natural fertilization as a side effect of pest control. Chemical fertilizer use was dropping along with pesticide use. The water circulation had another benefit. It prevented stagnant conditions that bred disease. Rice blast, a fungal disease, was less common in duck fields. The ducks were preventing plant diseases without anyone trying to make that happen. Farmers who'd spent decades trapped in the pesticide cycle were suddenly watching their fields thrive. No chemicals, no contamination, no resistance, just ducks doing what ducks do. And it was working better than anything science had engineered. But the real shock came when they calculated what this meant at scale. Producing millions of ducks wasn't something China could just wish into existence. They needed facilities, massive ones, and they needed them fast. What China built was the largest coordinated duck breeding operation in agricultural history. We're not talking about a few hatcheries. We're talking about an industrial-scale biological production system. Breeding facilities were constructed across multiple provinces. These weren't traditional duck farms. They were high-tech hatcheries designed for one purpose: producing pest control ducks at unprecedented volume. Each facility could hatch hundreds of thousands of ducklings per cycle. And there were dozens of these facilities operating simultaneously. The scale was staggering. To cover 49 million acres at 50 to 80 ducks per acre, China needed between 2.5 billion to 4 billion ducks. Billion with a B. And those ducks needed to be ready at exactly the right time, synchronized with rice planting schedules across the entire country. The breeding process started with selection. Not every duck breed works for rice paddies. They needed ducks that were efficient hunters, that could tolerate standing in water all day, that were hardy enough to survive in agricultural environments, that grew fast enough to be deployed at the right age. Researchers tested dozens of breeds, mallard derivatives, Muscovy crosses, indigenous Chinese breeds. They measured pest consumption rates, survival rates, growth rates. Every variable mattered. Once they identified the best breeds, the real work began. Female ducks were housed in climate-controlled facilities. Eggs were collected daily. Thousands of eggs. Tens of thousands. All transported to incubation chambers where temperature and humidity were precisely controlled. The incubation period for duck eggs is 28 days. That meant facilities had to plan production cycles months in advance to match regional planting schedules. The hatcheries ran like factories. Eggs moved through automated systems, candling stations to check viability, incubation chambers maintaining exactly 99.5 degrees Fahrenheit, humidity at 86% for the first 25 days, then raised for hatching. Everything monitored. Everything optimized. Any deviation could ruin an entire batch. When the ducklings hatched, they moved to brooding facilities. Newly hatched ducks are vulnerable. They need heat, protection, specialized feed to build strength before field deployment. The brooding period lasted 2 to 3 weeks. Thousands of ducklings in temperature-controlled barns. Veterinary staff monitoring for disease. Any sick duckling was immediately isolated. You can't risk illness spreading through populations this dense. The logistics were insane. Northern provinces needed ducks ready by early April, southern provinces by March, central regions somewhere in between. Every facility had to coordinate its breeding cycles with the agricultural calendar of its region. Hatch too early, and you're feeding ducks while waiting for fields to be ready. Too late, and farmers missed the optimal pest control window. Transportation became its own challenge. Millions of ducklings had to move from hatcheries to farms. Special ventilated trucks were designed for duckling transport. Routes were planned to minimize travel time. Ducklings can't spend days in transit. They needed to reach farms while still young enough to adapt to field conditions. The entire country's transportation network was mobilized. Trucks rolling day and night during planting season. Quality control was relentless. Each batch of ducklings was tracked, health records, breed information, hatch dates. Farms received ducks with full documentation. If a batch underperformed in the field, the data traced back to the specific hatchery, the specific breeding stock, the specific conditions. Continuous improvement through brutal data analysis. And the breeding program kept evolving. By year 3, the ducks being produced were measurably better than year 1 ducks. Faster pest consumption, better field adaptation, lower mortality rates. The facilities weren't just producing ducks, they were engineering them through selective breeding, taking the best performers from each season and using them as next year's breeding stock. The cost of building this system was enormous, but it was still cheaper than the pesticides it replaced. And unlike pesticides, the breeding facilities were a one-time infrastructure investment. Once built, they could produce ducks indefinitely. The economics worked. Barely. But they worked. What China created was unprecedented. A biological production system operating at industrial scale, coordinated across thousands of miles, timed to agricultural cycles, quality controlled like a manufacturing process. It was farming meets factory, nature meets engineering. And it had to work perfectly or millions of acres of rice would fail. But China pulled it off. The facilities delivered. Millions of ducks. Exactly when needed, exactly where needed. The breeding operation became the backbone of the entire rice duck system. And that's when the real scaling began. China scaled up fast. Province after province adopted rice duck farming. What started as pilot programs in a few regions became national policy. The government threw resources behind it. Millions of ducks were being bred specifically for pest control. Breeds were selected for their hunting efficiency, their water tolerance, their adaptability to rice field conditions. Farmers were trained in management techniques. How to release ducks, when to release them, how many per acre, how to protect them from predators. Training centers opened across the country. Agricultural extension officers who used to teach pesticide application were now teaching duck management. The knowledge transfer was massive. Supply chains were built to handle the duck populations. Hatcheries expanded. Transportation networks were established to move millions of ducklings to farms at exactly the right time. The entire infrastructure of rice farming was being rebuilt around ducks. And the logistics were brutal. Ducks needed to be synchronized with rice planting across climate zones spanning thousands of miles. Northern provinces planted in April, southern provinces planted in March. Every region needed ducks at exactly the right time. Not a week early, not a week late. Exactly when the rice seedlings were established enough to handle duck activity, but before pest populations could explode. Breeding facilities had to ramp up production to levels nobody thought possible. Millions of ducklings, all timed perfectly, all distributed across the country. Computer systems tracked planting schedules, duck breeding cycles, transportation logistics, and field conditions in real time. The operation looked more like a military campaign than a farming program. But China pulled it off. Farmers who'd resisted at first saw their neighbors' results and switched over. Word of mouth spread faster than official programs. The program spread faster than anyone predicted. Field after field converted to rice duck systems. And with each conversion, pesticide use dropped by nearly 100% in many regions. Chemical distributors saw their sales collapse. Pesticide manufacturers watched their biggest market disappear. But scaling the ducks was only half the challenge. Technology made the impossible possible. China deployed drones over rice paddies to monitor duck populations and pest levels in real time. High-resolution cameras mounted on autonomous drones flew regular patterns over the fields. They captured images of duck distribution, movement patterns, and concentration areas. They could spot problems before farmers even noticed them. The drones used multispectral imaging to detect early signs of pest pressure. Certain insects changed the way rice plants reflected light. The cameras picked up those changes. AI systems analyzed the images and identified problem areas. Farmers got alerts on their phones. Real-time pest management based on data most farmers couldn't even see. Ground sensors measured water quality and rice growth continuously. Temperature, pH, oxygen levels, nutrient concentrations, all tracked automatically. The data fed into AI systems that learned what conditions produced the best results. The AI discovered patterns human observers had missed. Optimal water depth for maximum duck efficiency. Best feeding schedules for different growth stages. Ideal duck-to-acre ratios for specific pest pressures. The AI learned fast. It discovered that certain duck breeds performed better in specific regions. The system identified ideal release times down to the day, not just by calendar date, but by actual field conditions, soil temperature, water level, rice, seedling stage. Every variable was analyzed. It predicted pest outbreaks before they happened. Historical data, weather patterns, regional trends. The AI crunched everything and forecast where problems would emerge. That allowed farmers to adjust duck populations preventively. It was predictive pest control, something that had never existed before. Farmers accessed the system through their phones. They'd get alerts about their specific fields, recommendations for duck management, real-time updates on pest pressure. The technology wasn't replacing the farmers. It was making them exponentially more effective, and the results kept getting better. Fields connected to the AI system showed even higher pest elimination rates. Even better yields? The technology was solving the scaling problem everyone said was impossible, but nothing prepared the agricultural world for what came next. Other pests started disappearing too. Weeds that used to choke rice plants were being trampled and eaten by ducks. Golden apple snails, an invasive species that had plagued southern rice fields for years, were prime duck food. The ducks ate them voraciously. Farmers had been fighting those snails with toxic chemicals for decades. The ducks wiped them out in weeks. The ducks weren't just targeting one or two pest species. They were creating a complete pest management system. Anything that threatened the rice became dinner. Moth larvae, beetles, grasshoppers, even small rodents that invaded the fields. The ducks hunted them all. And here's what made it even more powerful. The ducks prevented pest problems before they started. Traditional pesticides were reactive. You spray after you see the problem. But ducks were constantly patrolling the fields. They caught pest populations when they were tiny, before they could explode into infestations. It was prevention, not treatment. A single planthopper laying eggs in a rice field could produce thousands of offspring. Those offspring could devastate acres of crops, but a duck would eat that single planthopper before it ever laid eggs. Problem solved before it began. That preventative pressure was something chemicals could never provide. Farmers realized they weren't just eliminating pesticides. They were eliminating the entire crisis cycle. No more waiting for pests to appear, no more emergency sprayings, no more watching helplessly as resistant insects shrugged off chemicals. The ducks maintained constant pressure on every potential threat, and nothing could build resistance to being eaten. That was the fundamental breakthrough. Insects had evolved resistance to every chemical humans had created, but insects couldn't evolve resistance to predation. There was no adaptation that made you immune to being hunted and eaten. The ducks were a solution that couldn't be defeated. The pesticide industry watched in horror as their market evaporated. Billions of dollars in chemical sales were disappearing, not because of regulations, but because farmers were choosing ducks. The chemicals simply couldn't compete. And then China released the numbers that changed everything. Over 49 million acres of rice paddies had converted to rice duck farming. 49 million acres. That's an area larger than the entire state of Florida. All of it now operating without pesticides. The scale was almost incomprehensible. Millions upon millions of ducks deployed across the country. All of them eating pests, all of them replacing chemicals. To put that in perspective, that's roughly 30% of China's total rice cultivation area. Nearly a third of the country's rice production had abandoned pesticides completely. And it had happened in less than 5 years. Agricultural revolutions usually take decades. This took years. Pesticide use in those regions had dropped by more than 95%. 95%. Chemicals that had been considered absolutely essential were suddenly unnecessary. Fields that had been drenched in toxins multiple times per season were now clean. Water systems that had been contaminated were clearing. The environmental recovery was visible from space. Rice yields across the program were up by an average of 15 to 20%. Some fields reported even higher gains. Farmers were producing more food with fewer inputs. No pesticide costs. No contamination, no resistance cycles, just better results. The economics were undeniable. A farmer spending thousands of dollars per season on pesticides was now spending nothing. That money stayed in their pocket. The financial impact on rural communities was enormous. Farmers weren't in debt to chemical suppliers anymore. They were profitable, genuinely profitable. And it was all happening because China had released millions of ducks into rice fields. The solution wasn't complex. It wasn't high-tech genetic engineering. It was ducks. Natural, simple, elegant ducks. Enhanced with modern technology for coordination and monitoring. But fundamentally, ducks. But the most shocking part wasn't the scale. It wasn't even the results. The most shocking part was that it actually worked. Every expert had said, this was impossible. You can't replace industrial chemical agriculture with birds. You can't manage biological systems at continental scale. You can't solve modern pest problems with natural predators. The consensus was absolute, universal, and completely wrong. China proved them all wrong. The ducks weren't just working. They were working better than the chemicals ever did. Higher pest elimination rates, better yields, lower costs, safer for humans, superior on every measurable metric. The comparison wasn't even close, and it wasn't luck, it wasn't some fluke. It was engineering. China had taken a natural process and scaled it through technology, coordination, and sheer determination. They'd build breeding programs, logistics networks, monitoring systems, and AI platforms, all designed to make millions of ducks function as a nationwide pest control system. They'd turned biology into technology, The breeding programs selected for pest-eating efficiency, testing different breeds in different conditions. The birds deployed in year 5 were substantially better at pest control than the birds in year 1. Continuous improvement through selective breeding. The logistics networks moved millions of ducks with precision, timing arrivals to within days of optimal release windows, managing transportation across thousands of miles. The operation was flawless. The monitoring systems provided unprecedented visibility. Every field tracked, every duck population monitored, every pest pressure measured. The data was analyzed and turned into actionable recommendations faster than human managers could have dreamed. The agricultural world was watching in disbelief. Rice-dependent countries were sending delegations to study the system. Vietnam, Thailand, India, Bangladesh, Indonesia. Every major rice-producing nation wanted to understand what China had done. The answer seemed to be yes. The principles were universal. Ducks eat insects everywhere. Chemical companies were scrambling. Their entire business model was under threat. If rice farming didn't need pesticides, what else didn't need pesticides? The implications were terrifying for an industry built on selling chemicals. China had sparked an agricultural revolution, not with new chemicals, not with genetic engineering, but with millions of ducks and the technology to manage them at unprecedented scale. And the world was shocked because the simplest solution turned out to be the best one.